Hi, I'm Luke Kane. Welcome to Algebra 1. Today we're going to continue to simplify rational expressions, and specifically we're going to look for the values that make a rational expression undefined or zero. Basically, there are 2 points that need to be kept in mind during this exercise. A rational expression equals zero when its numerator is zero. And that seems reasonable enough because 0 divided by anything is going to be 0. So to set a rational expression equal to 0, all we need to do is set the numerator to 0. And it has to be the entire numerator. And then, in a similar fashion, to determine when a rational expression is undefined, we look for the case when its denominator is 0, because we cannot divide by 0. Dividing by 0 is definitely not an operation that's defined in arithmetic. So let's look at a couple of examples of how we might do that. We have 4 rational expressions on the right-hand side of our page, and we want to turn each of them into 0 or to turn each of them into an undefined expression. So let's start with the first one right here. So we have A, which is y minus 5 over y plus 9. We want to know, first we want to know, when is it 0? Well, we know it's 0 when the numerator is 0. What's the numerator? Numerator is the top number. Top number is y minus 5. The rational expression is going to be 0 when the numerator is 0. So that means that y minus 5 is going to equal 0. What's y going to equal? Well, we add 5 to both sides, and we discover that y is going to equal 5. That's going to make this expression 0. So second problem, when is it undefined? It is undefined when the denominator is 0. Alright, so we set the denominator. The denominator is this guy, the bottom number. Y plus 9 equals 0. So what does y got to be? Subtract 9 from both sides to find out, and y equals minus 9. Pretty straightforward. Alright, let's do B. B is this guy over here, and so copying that, that's 7r over r squared plus 5r minus 24. Alright, so the first question is, when is that 0? Well, it's going to be 0 when numerator is 0. So set the numerator to 0. 7r equals 0. Divide both sides by 7, and 0 divided by 7 is 0. And this, of course, is 1, so that went away. Second one is, when is it undefined? Well, it's undefined when the denominator is 0. So we set the denominator equal to 0 to find out when this rational expression is undefined. So we have r squared plus 5r minus 24 equals 0. So we have a quadratic, and it's in standard quadratic equation form. So we know to solve this, we're going to have to factor out 2 binomials if we can. Well, the leading coefficient is 1. That makes life easy. The first terms are going to be r. R times r is r squared. When I multiply, so minus 24 is going to equal product of 2 numbers. So we want to find 2 factors that equal minus 24. Well, the only way that 2 numbers multiplied are going to give us a minus 24 is if one of them is plus and the other one is minus. So what are the factors of 24? And of course, the factors have to add up to 5. So let's try minus 24 times 1. That equals minus 24. But minus 24 plus 1 equals minus 23. Oh, that's not even a right sign. So we're going to make the bigger absolute value. We're going to make that negative. I'm sorry, make that positive, right? Because this is positive. All right. So let's try 8. Okay, 8 is bigger than 3, so let's make that a positive 8 times a negative 3. That's going to be negative 24. 8 minus 3 is 5. So that works. So it's 8, because that's plus goes here, and the minus goes here. And again, this equals 0 when that equals 0. Right? So r plus 8 equals 0. And that's going to be 0 when r equals minus 8. Similarly, it's also going to be 0 when that's equal to 0. So r minus 3 is going to equal 0 when r equals 3. So we have two solutions for when it's undefined. r equals minus 8 and 3. Okay, what's the next one? C. 25. Oh, we just did C. No, we didn't. We didn't do C. Sorry, getting confused. C. 25d squared minus 1 over 4. C. 25d squared minus 1 over 4. So the first question, when is that 0? Again, it's 0 when the numerator is 0. When 25d squared minus 1 equals 0. Well, we can factor that because this is a difference of squares. This is the same as 5d squared minus 1 squared equals 0. So I can factor out 5d plus 1 and 5d minus 1. They're going to equal 0. This is going to equal 0, and that's going to equal 0, and that's going to yield my solutions for when this rational expression is 0. So I have 5d plus 1 equals 0. Subtract 1, subtract 1. And I get 5d equals minus 1. Divide both sides by 5. That cancels. I get d equals minus 1/5. All right, so the next question. When is this undefined? It's undefined when the denominator equals 0. But wait a minute, the denominator is 4. So 4 is not 0. So it turns out this is a case where this rational expression is defined for all values of x, because there is no value of x that is going to make the denominator 0. Interesting case. So and of course this is a polynomial, right? A0 equals 4. All the other AIs equal 0. So it is a polynomial, even though it's kind of simple polynomial. All right, what was the last one? The last one was 2 over 3p minus 1. 2 over 3p minus 1. And this is d. All right, again, same deal. When is this 0? Well, 2 is not equal to 0. So this is never, this rational function, I'm sorry, this rational expression is never 0, because there is no x that I can put into the numerator. Is never 0, sorry. Because there's no x that I can put into the numerator to make it 0. So it's never 0. How about, can it ever be undefined? Okay, well, it's undefined when the denominator is 0. 3p minus 1 over 2. I'm sorry, I actually flipped that. How about that? Sorry about that. 2 over 3p minus 1. And that's undefined when the denominator equals 0. So that's going to be 3p minus 1 equals 0. Add 1 to both sides, and I get 3p equals 1. Divide both sides by 3. And p equals 1/3. Okay. Let's see what do we learn today. All right. So what did we learn? Well, we learned how to make a rational expression 0. or to discover when a rational expression is zero is probably a better way to put it. We also learned to discover when a rational expression is undefined. A rational expression is zero when its numerator, the number at the top, is zero, as shown here. Doesn't matter what the denominator is, anything divided by zero is going to be any zero divided by anything is going to be zero. So it doesn't matter what the denominator is, as long as the numerator is zero, the rational expression is going to be zero. And similarly, if we want to find when a rational expression is undefined, well, we set the denominator equal to zero, because we cannot divide by zero. It is not allowed in arithmetic. It is a senseless operation. It makes no sense at all. So, to discover when a rational expression is zero, set the numerator to zero. When we want to discover when the rational expression is undefined, set the denominator to zero, and in both cases, solve for the variable. Okay, next time, in the next video, we're going to look at rational expressions and how to express them in lowest terms. If you need more practice with this idea of rational expressions and finding when they're zero, when they're undefined, you can look at an example on page. It'd be example 2 on page 447. So if you want more practice on this concept, turn to page 447 and look at example 2. Till next time, I'm Luke Kane. Thanks for watching. Bye now.